another line charge like this, and the charge densities are plus lambda and minus lambda. Their charge densities are plus lambda and minus lambda, and distance between them is 2. So we have to find electric field midway between the two line charge. So we have to find electric field at a point which is lying, suppose there is point P in the middle, which is as distance r from this side and r. So we have to find the electric field at point P. So both of you understood the question. We have to find electric field at point P. Okay. So first I am asking Shravya, how we will proceed for this question? What concept I have to apply? Shravya, do you have any idea how we will proceed to find the electric field between these two line charges, plus lambda and minus? Any idea, both of you, Mahmoud? How we will proceed to find the electric field between the two line charges?
We will use the formula F by Q naught.
What formula?
E is equals to F by Q naught.
F by Q naught. So
Sir, what is lambda here?
lambda is charge per unit length, linear charge density. You may have heard about
Yes, sir.
this. Linear
So we
charge
can
density.
use linear charge density and then find Q from there. And we can equate that to electric field formula, like F is E is equal to F by Q naught, and then substitute the value of Q.
Okay. You agree with this, Navuna? We will do same thing or something else. You're also saying the same thing, I think, to find the electric field and then force, right?
Yes.
So, let us see. Here we have to find the electric field, and see, there is no question of force here. If you see, let us see this point, this point P. So there is a question of force only when there is a charge at point P. There no charge is present. So how we can find force? To find a force, there must be a charge present at point P. So there is no question of force to finding the force or something. There cannot be such method since there is no charge at point. So that is the definition of electric field. You know, how we find electric field is force upon charge. That is the definition of electric field. It is only valid if some force kind of thing is given. But here there's no such kind of charge is placed, points this place, nothing is like that. So if you remember the applications of Gauss, which you may have studied in the starting of in the first chapter, starting of class 4. So using that, I will dictate you first how some applications of Gauss law, which you may have studied, but you may have followed that. So I will remind you kind of some examples or some applications of Gauss. So you may have heard about applications of Gauss law, right? Shreya and Memuna.
Yes.
So here we have to apply that applications of Gauss. What applications of Gauss law is? Which is that like applications of Gauss. Applications. In applications of Gauss law, what we have seen, like we had a line charge. We had different cases. In one of the cases, we had a line charge. Suppose linear charge density lambda, and we have to find electric field at a point P. For that, what we did, we have applied Gauss law. If you remember like this, you may have considered a cylindrical Gaussian surface. If you remember that, you may have considered, suppose you have to find electric field at a point P. So you may have considered the Gaussian surface like that. And I'm trying to remind you what you may have studied. And by using uh, this, we have used as a Gaussian surface. And then we have applied the Gauss law over this area. And you may have find the formula for electric field. If you remember, like E is equal to 1 by 2 pi epsilon naught lambda by. Do you remember this formula?
Yes, sir.
So this is the this was the electric field due to a line charge. So in this formula, all those kind of things, finding force and all those kind of stuffs are considered. And considering that, we have found this result that electric field at a point due to an infinite line charge is 1 by 2 pi epsilon of mu. Gauss law already considered those definitions, and using those definitions, Gauss law is given. And by applying Gauss law, we have find this formula of electric field at a point P situated at a distance r from a line. So now onwards, for a line chart, we will directly use this formula, right? What my point? So this is for what is Gauss law. We have different cases. You may have heard about sheet of chart. Like if there is a line sheet of chart, and electric field due to this sheet of charge, you may know the formula E is equal to sigma by 2 epsilon naught, if you remember.
Yes.
The charge density is sigma. So these were applications of Gauss law. So we are going to directly apply those applications, those formulas based on. So here in this case, we will directly apply the formula. So actually, this is the line chart. And we know that if this is positive charge, if this is positive charge, electric field always will be away from the charge. So due to this line charge, electric field will be towards right, and it is negative charge. So we know that for a negative charge, electric field is towards the charge. So if we want to find net electric field at point P, we will add the electric field due to both the charges, due to plus charge and due to minus. Because both are in the same direction. So net electric field at point P will be sum of the electric field due to positive charge and negative. Both of you got the point or no? Memuna, have you got the point?
Yes.
Rabia?
Yes, sir.
So now we have to put the formula. We have to put the value of electric field due to the positive charge. So what is the value of electric field due to this positive charge? That is 1 by 2 pi epsilon naught lambda upon the distance is capital. Similarly, the electric field due to negative charge is 1 by 2 pi epsilon naught lambda. Here we have already taken the direction, so we don't have to put plus lambda and minus lambda since we have already considered the direction. We have already considered the direction towards right due to negative. So here we are going to put only magnitude, not signs. Okay. By mistake, we may have take plus lambda and minus lambda and we put the electric field as 0, which is wrong. If you see, your first option is also, if you see the options, first option is also 0, and we do the mistake. So here we don't have to consider sign, we have to take only magnitude. Since we have considered the direction, so in that direction, sign has already been considered. What my point? So here we don't need to take sign, we only have to take magnitude. So if we see, okay, so now if we find the resultant field, that will be equal to, that will come as if we are putting the value uh, now we will add both the values. So we will get the value as 1 by 2 pi epsilon naught to lambda by r. So it will come as 1 by 2 pi epsilon naught lambda. So if we see, The correct option is 1 by 2 pi lambda. C is the correct option. C is the correct option. 1 by 2 pi 1 by pi epsilon naught lambda. Right? So both of you understood this. Pen it out, please ask. Any doubt? Shavya, Mamuna, or both of you
Yes.
understood this one?
No doubt.
You're so this question we have to use application of Gauss. Yes, we have to use application. Okay, moving to the next question. The next question is a hollow metal sphere. See question number 14, which we are discussing. A hollow metal sphere of radius r. A hollow metal sphere of radius r is uniformly charged. The hollow metal sphere of radius r is uniformly charged. The electric field due to the sphere, the electric field due to the sphere at a distance r from the center. Okay. Option 1 says increases as r increases for r less than r and for r greater than r. Option B says 0 as r increases for r less than r and decreases. So we have checked for the variation of electric field. It's charged hollow metal sphere. So let me explain you the question, what it is saying and what it is asking. The question says, first understand the question. I'm explaining it to you. The question says, there is a charged hollow metallic sphere. Suppose this is a charged hollow metallic sphere and charge on this sphere is Q and its radius is R. So we have to find electric field variation with distance. We have to find electric field variation with distance. Electric field variation with distance. How electric field varies from the center. If we are moving from center away from the center, then how electric field varies. So basically we have to see that. If you see the option, it says it increases with R and up to less than R, it decreases and so. It's a NEET 2019 question. So first, Shravya, tell me how we are going to solve this question. What we have to do, what concept we have to do in this question. Have you understood? First, have you understood the question?
So could you share the question again? Could you explain this question again?
You want me to explain the question again?
I mean, could you share the question again?
All right. Let us see the question. Question number 14.
So we can use electric fields formula, and then F is equal to 1 by 4 pi epsilon naught. So E would be KQ by R squared. So we can use that. Electric field is equal to KQ by R squared for point charge.
But if you see here in this question, we have a metal sphere, right? So how we can use the formula of point charge for a metal sphere? Have you understood what I'm saying? I'm saying
Yes.
that you're saying that we have to apply the formula of electric field 1 by 4 pi epsilon naught Q by R square. Okay, but in the question it is given that there is a hollow metal sphere. So will it be suitable for applying that formula here?
No, sir.
Since we have the Mamuna, any
Yes, sir.
thought on this question? Yeah. Have you understood the question?
Yes.
So any idea to proceed for this question? She's saying that Shabya is saying that we have to apply the formula of 1 by 2 pi epsilon naught Q by R square. So is it how we can proceed or is there any?
Sir, can we apply Gauss law here?
Yeah, somehow you are going to the right track. So we can apply Gauss law here. We can apply Gauss law here. And if you remember Gauss law correctly, if you see, we have discussed the slide of Gauss law here. So here we have found electric field due to line charge, due to charge sheet. But if you remember in Gauss law, you may have studied about spherical conductors also. And you may have found electric field at a distance, suppose there is a point P at a distance R from the sun. So if you remember, we have considered Gauss law of radius R, considering this as a radius. You have considered the Gaussian surface, and you may have find electric field as 1 by 4 pi epsilon naught capital Q over. Can you remind that? Electric field was like this in all direction if it is positive charge. So electric field is away from the charge like this, like this, like this, like this. The electric field at a distance r from the center due to a conducting sphere is given as 1 by 4 pi epsilon of Q by R. This is applicable for R greater than, that is outside the sphere. But if you remember, for a conductor, electric field inside is always zero. Electric field inside a conductor is zero. So you have find this expression of electric field from Gauss law. Can you remind this one? Both of you, do you remember this formula? Shavya, Namuna, do you remind? Do you remember this formula? You may have found the electric field using Gauss law. That is 1/epsilon naught Q by R. So Shravya, actually you were right at the beginning, which you were saying that electric field due to a point charge. Up to some extent, you were right, but you have to explain it differently. What happens actually is electric field of a point charge and electric field of a spherical conductor. The expression for both are same. The expression of, if you remember, the electric field into point charge is also same. Like if you remember, if we had a point charge, there is a point charge, a small q, and at a distance r, there is a point p. Then the formula for electric field was same, 1/4 pi epsilon naught q by r square. Right or wrong? So this was the formula. Here also electric field is same, 1/4 pi epsilon naught q by r. The difference is that here the charge capital Q is on the sphere, and we have to take distance from the center. And inside the conductor, if we consider inside the conductor, then electric field is zero for R less than. Can both of you understand this point? These two
Yes.
expressions which I have written. So this is the difference between point charge and sphere. In case of conducting sphere, electric field inside the sphere is always, and outside the sphere, the expression is same as point charge. So you may write a note that electric field electric field due to a spherical conductor is zero
Sir,
at
could you repeat it?
inside. Electric field electric field due to a conducting electric field due to a conducting charged sphere due to a conducting charged sphere is zero at internal points. Is zero at internal points. In bracket you can write r less than. In bracket you can internal point means for points which have their distance less than radius of the conductor. Here capital R is the radius of the conductor. Here what is capital R? It is radius. Similarly, full stop. After full stop you can write for outside point, for outside point, for outside point, you can write in bracket r greater than equal to r. For outside points, in bracket you can write r greater than r. the spherical conductor or outside point, the spherical conductor can be treated as can be treated can be treated as a point charge for outside points. The spherical conductor can be treated as a point charge placed placed at its center for outside point. The spherical conductor can be treated as a point charge placed at its center. Have you got my points, both of you? So for outside point, the electric field will be same as a point charge. So for the given question, what we have got, if here we see, we can say that electric field is zero for what? If the point is inside, suppose point P is here, that is R less than, and electric field is equal to 1 by 4 pi 1 by 4 pi epsilon naught q by r square if r is bigger. You must remember that here we must have a small r, not capital R. Since the point is outside this sphere and the distance from the center is, here you must note the r in the expression. You must note r in the expression. It should be small r. For outside point, it should be, by mistake sometimes we write capital R. For this surface, if the point is on the surface, then in this expression we will have capital R, but for outside point it should be small. So this is the formula. Now if you see, now considering this, now uh, again if you see, for outside points, from this expression we can say that electric field, from this expression we can say that electric field decreases, electric field decreases as R increases, electric field decreases as R increases. Now coming to the different options, now see the options and both of you give your answers. Now go through the options and give me your answers. So Shreya says it's B. Lamuna says it's B. Can you please tell Shravya why it is B?
So for external points, electric field decreases like when R increases.
Now see, what you're saying, that is correct. But you see the option D. What is it says?
Oh, I did not see the next part.
Okay. So what is the correct option now? Correct. So B is the correct answer. B says, as we explained, 0 as R increases for R less than 1, that is internal point, and decreases as R increases for external point, that is greater than. So with no doubt, B is the correct. So both of you understood this question now. This is very important question asked in NEET 2019, and such type of questions are asked every year. In this 2000 also, some question has been asked like this. And if you see one more thing, sometimes you may have been asked like to draw the graph of electric field versus distance. So the graph of electric field versus R. Mamuna, can you tell me how will we graph for the variation of electric field versus R?
No idea.
Shravya, any idea how the graph will look like if we draw a graph for the variation of E versus R? See, see as we have discussed, for suppose uh, in y-axis we have electric field and on x-axis we have R. So suppose this point is R. So up to this point there is no graph since electric field is 0. Suppose this is the origin, and from R onwards, for capital R onwards, the point becomes external point. So what will be the electric field? It will decreases like this. If you see the electric field E is E proportional to 1 by R for external point. This region is for internal R less than. So there should not be solid graph here. It should be dotted line because electric field is 0 in this region. So here it should be a dotted line. But if you come to this point, this represents surface at R equal to capital R. This represents surface. So on this surface, if you see this point, it represents surface. So on the surface, what is the value of electric field? On the surface, or on the surface, on the surface, R equal to capital R. So what will be the value of electric field? E will be equal to 1 by 4 pi epsilon naught Q by R.
Elinda,
Sorry, is someone saying something? So on this surface, the value of electric field is 1 by 4 pi epsilon naught Q by R square. Okay. So, Shravya, have you understood the graph, or should I explain to you again? I think you were disconnected. I'm explaining to you again. We were drawing the variation of, we were drawing the graph for electric field versus distance R. We were drawing the graph for E versus R, right? So to draw the graph, we have used the same expression of electric field equal to 0 for R less than R. So in this region, there is no graph. Okay, so in this region, there is no graph since uh, electric field is 0 for this region. So we have put no graph for the region. I have drawn a line, but actually there is no graph in this region. And if you see for the region R less than R, it means for outer region, the graph looks like this. So the actual graph for variation of electric field with this distance due to a conducting sphere will look like this. I will draw you the fresh graph. It will look like this. It will be like this will be a dotted line. This is R, and the here the value, what is the value? It represents the surface. This R represents the surface. So here the value of electric field will be equal to 1 by 4 pi epsilon naught Q by capital R. Because this point represents surface, R equal to, here R equal to capital R. In this region, R less than R, so no field, zero field. Here no field, zero field. This region represents surface. So on the surface, value of electric field is this. That is 1 by 4 pi epsilon naught Q by R square. And this region represents R greater than. It's outside region. Here electric field. So is there any doubt, or both of you understood this graph? If any doubt, please ask Shravya and Manu. Any doubt in this graph? Because this graph is important and asked repeatedly in meeting. So, ma'am, have you understood this?
Sir, could you explain this again?
Shravya, have you got the graph?
Sir, could you explain this again?
Okay. So, can you please help me where you are unable to understand, from which point or the whole graph should I explain? Or any specific
Sir,
point you are unable?
like, why is that graph curve?
Okay. A good question. Why the graph is curved? Correct. Why it is not a straight line?
Yes,
Maimuna,
sir.
can you explain this? Why the graph is not a straight line? Okay. See, if you see this expression, the electric field expression for zero, it is clear, right? No graph. So for this
Yes,
reason,
sir.
I think both of you clear.
Yes, sir.
For outside reason, we got equal to 1 by 4 pi epsilon Q by R. Right? Okay. So here if you see the sum of the terms are constant. Let me if you see these terms, these are constant, right? 1/4 epsilon naught is constant, given charges. So
Yes,
from
sir.
here, you can say that E is proportional to 1 by R. Now, here we have E is inversely proportional to R. So let me give you some idea graph first. Actually, generally we teach in basic mathematics. When I start a class, usually I teach basic mathematics. And in that class, usually I explain about the graphs. So let me explain you something about graphs. Like, suppose you have a thing like y equal to x. Suppose you have a equation like this. So all of us know the graph for y equal to x is a straight line, right?
Yes, sir.
And it is how the graph of y equal to x. Uh, are you aware of the graph y equal to x? Do
Yes,
you
sir.
know how it is?
So straight line.
Correct. Graph of y equal to x is a straight line and passing through the orbit, right? Why it is
Yes,
passing
sir.
through orbit? Because at x equal to 0, y equal to 0. And as x increases, y. So here you can say that y is proportional to x. Y increases. So here you see that x is linear, nothing like square or cube. So in that case, the graph is straight line. You may have heard like those equations which satisfies this formula, y equal to mx plus c kind of thing, where c is a constant. Or you can say if y is proportional to x, in such cases, graph is a straight line, right? In such cases,
Yes,
the
sir.
graph is a straight. Similarly, if we have, and in this category, we may have equation like y is equal to 2x, y equal to 5x, all will have a straight line. Another category is like if you have the terms like y equal to 1 by x. Okay, so in such cases, how the graph varies? If x increases,
Y decreases.
y decreases, right? So here we have graph like this. It is called hyperbola. It is called rectangular hyperbola for such cases. It could have been a straight line, but if if we draw the graph like this also, this is also decreasing, right?
Yes, sir.
I have drawn a graph like this. This is also decreases with x, right or wrong? But
Yes.
the graph is not a straight line because for to have a straight line, the graph must be of this form. If it is not of this form, it cannot be straight line. So in such cases, actually here you can see for such equation where x y equal to 1, actually you see here we have x y equal to 1, or it is a constant, right? If we are getting a term like x y equal to constant, In such cases, graph is curved. Got it? You may remember this is a standard case of in mathematics we studied like this xy equal to c square or a constant. So if it is constant, the graph is called rectangular hyperbola actually, but you don't remember that much. You can just remember that if the thing is like that, xy equal to constant, then the graph will be like this. Since
What
x is
it's
decreasing, what it
yes, sir.
so similar is the case with that. If you see, uh, if you see that one, there we had E proportional to 1 by r square, right?
Yes, sir.
So we can say E into r square is a constant.
Yes, sir.
We can say or not. So the graph must be like that. What we have said, like this. This is what we were drawing. If you check that graph, if you see, you can check this. It's not a straight line, it's curved. So
Yes,
that is why here we are drawing a curve. If you have a thing like that, inversely proportional kind of thing is coming, there always be a curve. If directly proportional kind of thing is coming, then we have a straight line. But if inversely proportional kind of thing is coming, you always have curve. What it?
okay, sir. Yes, sir.
So that is why the curve is not a straight line. So shall we move ahead? Both of you got the point now?
Yes.
Mona and Shabir, both of you. Okay. Now question 20. Both of you read this question 20. What it says and give me your answers. Read the question and based on application of question. So Shabir is saying it's 0. Okay. And what's your answer, Mamuna?
Sir, B option?
B, 0. Can you explain why it is B? Mamuna, why it is B? Shravya, what is B?
Like in previous question, we discussed the electric field would be zero if R increases for R less than the capital R.
Sir,
Correct.
also the electric field inside a conductor will always be zero, right? So
Yes, sir.
Yes, yes, both of you are correct. Since here, actually this question is a trap. If you see, they have given the electric field at a distance 3r by 2 from the center as E. Actually, this is a trap for these students. There is no use of that E. If that could have not been given also, we can straightforward say that the electric field will be zero, since the distance r by 2 from the center itself means that the point is internal. So electric field means got it. So B is the correct. Both of you got. I think no need to solve it, right? Okay. So this one need 2010. Okay, let us move to the question number 15. This question seems to be lengthy, but it is not lengthy actually. This is very easy question, but it seems like this question is tough. So both of you go through this question 15 and explain me what the question is saying. So first, both of you go through question. So have both of you gone through the question? Question 15. So let me explain you the question, what it is saying. So, what was the question number 15? Interesting. So what question 15 is saying that, let us see. Is saying that an electron falls from rest in a vertical distance h in a uniform and vertically upward directed electric field E. The direction of the electric field is non-reverse, keeping in the magnitude same. The protons are not to fall from rest in the same vertical to distance. The time of fall of electron comparison to, it is very the question. So let me explain you very in a easy way what this question is saying. The question says that, suppose, let's first understand the question. Suppose in a region, suppose I have a region in which electric field is E, correct? Like this. Suppose it is vertically upward direction. Suppose electric field is in vertically upward direction. And suppose there is a electron. So what will be the direction of force acting on the electron? Mamuna, what will be the direction of electric force, electrostatic force acting on the electron? Suppose we have an electric field in upward direction and suppose I have an electric field in the upward direction, downward, correct? Shravya is saying downward. Mamuna, will it be downward
Yes,
or
sir.
upward? Electric field on electron will always be opposite to the electric field, right? So force on the electron will be in downward direction. Correct?
Yes.
So due to force, the electron will move downward. So suppose it falls through a distance h. It falls through a distance h in the vertical direction. Till now, both of you got it. Now what happens? Now the question is saying that the direction of electric field is reversed. What we did? The direction of electric field is reversed. Electric field becomes downward. Previously it was up. And now proton, proton is having plus charge. So a proton is allowed to, what will be the direction of force on the proton? Shabya, what will be the direction of force on the proton?
Opposite?
Opposite. Why opposite? The charge on proton is positive. Charge on proton is positive. So it will be same as direction of electric field. Correct. Downwards. It should be downwards. Same as the direction. So direction of force on the proton will be same as the direction. So both electron and proton will fall down. Now again, electron falls through distance. Suppose same distance h. Right? So now we have to find, it is also falling through distance. So now we have to find the relation between time taken. Suppose during falling through height h, electron takes time t and proton takes time t2. So we have to find relation between te and t. We have to find relation between t and t is greater than Tp, or T is equal to Tp, or T is less. We have to find that only. That. So not more than, and means we only have to find the relation between T and T. That's all. So Maimuna, can you say what concept we should apply here? Here it is obvious that we cannot apply Gauss law, right? It's not a case of Gauss.
Yes.
So here we have to apply the simple definition of electric field, which you were saying in the first question, very first question. E is equal to F by something kind of. So give me some clue how to proceed, Mamuna. Shravya, can you give some clue how to proceed? See, to I will give you, actually, I don't have much time now. I will explain you a little quickly, but I will, first I will give you an idea. sometimes prefer solving a numerical. So first we have to identify. I will give you this question as a homework in assignment. I will give you this question. But before that, I will explain you something how to proceed and how to approach numerical. So it's a generic, not related to this one. It's here I will relate with this question. Here you can see what you have been asked. See, here we have been asked about time, right? The relation between time. And in the question, if you see, you have given distance, correct? You also have force. So force means acceleration. There is a force, there must be acceleration. So there are three things you are getting. You have in hand. What you have in hand? You have acceleration, you have time, you have distance, right? And so you must have to use a equation which contains all these three, which contains all these three physical quantities. That contains acceleration, that contains time, and that contains distance. Are you getting my points, Shravya?
Yes.
Okay. Mamuna, Maharaj, are you getting my points? What I'm trying to say? So it's a generic
Yes.
problem question. First, you have to find the things which are given and what you have to find it. So here we have to find the time and we have given acceleration. We have given acceleration and distance. So we have to search for an equation which contains all these three. If you remember, you have studied in class 11 itself an equation S equal to ut plus half it is. Have you seen this equation? No, no. This is the first equation in fact we studied class 10 only, class 9, 10, right? S is equal to ut plus. So if you see S is equivalent to here, H, S is equivalent to H, U is already 0. If you see initial they are dropped, so U is already 0 and acceleration is given. You will say, sir, how acceleration is given? So acceleration is given. You have given the charge. So here acceleration, how you can find? Electric force. Electric force upon mass. What is electric force? Charge into electric field divided by mass. So acceleration, here you can find, and you have to find the relation, the time. Okay. So I have given you a clue how to. So the equation will become like this. If you see, the equation will come like h equal to half at square, and if writing in more, it will come as like this. H will come as like this. H will be equal to, if I put acceleration as electronic charge is here E, charge on electron and proton both are same, E upon M into T. So we know that small e is also constant, capital E is electric field, that is also constant. So from here, what you can define, H is proportional to T square by M, and from here again you can say the time is proportional to mass, and again you say time is proportional to root of mass. Have all of you got this? Time is proportional to mass. Got my point or not?
Yes.
Have you have you understood this journey? How we move from this point? How we move from this point? See this point from this point to this point. Have all of you good? We have put t equal to 0, then we got this. Other things are constant. This is a constant term, and only variable is mass and time. So we put it like this. So now tell me, which is having more mass, proton or electron? Quickly, which is having more mass, proton or electron? Obviously,
Electron.
mass of proton is greater than electron.
Proton is
Electron is
greater.
very light. Correct. So, which will have more time, proton or electron?
So could you repeat again?
Which is having more mass, proton or electron?
So proton is having more mass.
So, which will have more time, which will take more time, which is having
Proton.
greater mass. So, obviously, proton will take more time. So, now coming to this question, if you see, this is time of fall of the electron compared to the time of fall of the proton will be smaller or equal? Obviously, it should be smaller. Time of
Smaller.
proton is greater, so time of electron should be smaller. So correct answer is A.
A.
Have all of you got this answer? It should be A. Time of electron should be small. Got it, Namuna? Shravya?
Yes.
Yes.
All of you got this? So this is how we will proceed for solving numerical question. So I will give you you will get that, and in next class we will discuss the question. So if you have any doubt, you can stay, otherwise you can log out. Thank you.
Thank you, sir.
Thank you, sir.